The melting point of rubidium chloride is 682 degrees Celsius, while that of sodium fluoride is 988 degrees Celsius. The main reason for this fact is, okay, so the melting point of ionic compound means it depends on the lattice enthalpy. So we know that the lattice enthalpy is the energy released when requisite number of gaseous positive and negative ions combine to form 1 mole of ionic compound. So higher the value of lattice enthalpy, greater will be the stability of the compound and greater will be its ease of formation and higher will be its melting point. Now, the value of lattice enthalpy depends on two factors. One is charge on the ions. The higher the charge on the ions, greater will be its force of attraction and hence larger is the amount of energy released. Means more will be the lattice enthalpy. If the lattice enthalpy is more, melting point also will be more. So, in case of rubidium chloride and sodium fluoride here, rubidium is 1 plus, Cl is minus, sodium is plus and F is minus. Means charge on the cation and anion is same in both the cases. So, I cannot consider charge to explain lattice enthalpy and melting point here. So, what is the other factor which affects the lattice enthalpy? Size of the ions. The second factor is size of the ions. We know highly charged species are rare. So, what is the other factor? The internuclear distance between the ions becomes more important to explain the lattice enthalpy and melting point. If the size of the ions is large, internuclear distance will be more and force of attraction will be less. So, while in case of small ions, internuclear distance is less, so force of attraction will be more and hence melting point also will be more. Okay. So, if you see in case of sodium fluoride, because of small size of sodium ion and fluoride ion, the internuclear distance will be less. So, internuclear distance is less means force of attraction will be more. So, obviously melting point will be more. So, sodium fluoride melts at high temperature compared to rubidium chloride because of the internuclear distance. The internuclear distance is greater for rubidium chloride than for sodium fluoride. So, that should be your answer. Molar mass of sodium fluoride is smaller than that of rubidium chloride. That is wrong. Bond in RBr has more covalent character. That is also wrong. Difference in electronegativity of rubidium and bromine is smaller than that of sodium and fluorine. That is also not correct explanation for the melting point here. What is the correct point here? The internuclear distance is greater for rubidium chloride than for sodium fluoride.